Okay, guys, today we are going to discuss actually Newton's laws of motion. Okay, you please write down laws of motion. Okay, actually, Newton has given three laws basically. Okay, the second law is very important, but still we have to study all the laws. Okay, what is the first law actually? First law is what you see. First, you understand. Say this is one object. Okay, this is stationary. So it means its inertia is at rest only. Okay, inertia is at rest only. So until and unless you apply some external force, you cannot make it moving. Okay, it means you cannot change the inertia. Similarly, say this object is already going, okay, with some velocity. Well, and unless and until you cannot make it stop, okay, or you cannot change the direction of velocity. So what does the first law says? First law says that until and unless application of a const application of an external force. Remember, external force required, not internal. External force. Until and unless application of an external force, a stationary body always remain stationary and a moving body always keeps moving with constant velocity. With constant this is called first law of motion. Any doubt? Unless and until say this is a say passenger bus, okay? We have lot of passengers inside. If all the passengers start pulling each other, okay, then the bus cannot move. The bus will always remain at the same place only, okay? But to keep the bus, to initiate the movement of the bus, one passenger must come come to the ground and push it from outside, okay? Then only the bus will start moving. Because when the passenger pushes the bus from the ground, this force becomes an external force. But when the passenger was inside and they are pushing each other, the force becomes internal force, okay? So internal force cannot change the inertia of an object. Okay. Any doubt?
Sir.
Okay. Then second law is very important. Say this object is going, okay? So it has some mass, it has some velocity. So if I apply some force, okay? So its momentum will be changed, okay? Say the new momentum is m into v, okay? So this is the final momentum and this is the initial momentum, okay? And to change the momentum, say I take some time delta t, okay? Then second law says that the rate of change of momentum is always equal to the applied external force, okay?
Excuse me, sir.
Okay.
Sir, I have a doubt.
बोलिए.
Sir, like if we are sitting on a scooty and we just start moving here and there, so the balance of the scooty will get disturbed and the scooty can fall. So it means we are not the external force, right? Because
Right.
we are not getting up and pushing the scooty.
First of all, you see, scooty falls just because of gravity, okay? Okay? And scooty also sometimes it may move little bit forward or backward also because of friction only, friction, okay? Because the gravitational force is becoming external force and the friction also becoming the external force, okay? It is not because of just you are giving some force, that is why actually scooty is falling down, okay? Just because of 2 points. First point is gravity and second point is friction, okay? If friction is not there, if gravity is not there, whatever you are doing, the inertia of the system means you and scooty always remain same only. Okay, it cannot. You think of you are having in space. Okay, you cannot do the change the inertia actually. Okay,
Okay, sir.
uh, if friction is not there, you see, uh, friction is actually external force. Okay, you see, say this is a place, okay, where friction is totally not there. Okay, can you walk? Can you move? Can you move? You cannot. You cannot. Totally, you cannot. If friction is not there, you cannot move. You will be always at this place only. If there is a wall, if you push a, if you push the wall, then you will move back. That wall will give some normal force, na? That will become external force. Okay. If the wall is not there, you cannot. You cannot move. Not at all. Not at all. But you can fall down. You can slip down because of the gravity. Okay. Clear?
Yes, sir.
Good. Nitish, are you getting?
Yes, sir.
Uh, if you want to change the momentum rapidly, you have to apply more force. If you want to change the momentum slowly, you have to apply less force. Okay, that is very important. That is second law actually. The rate of change of momentum is proportional to the applied external force. It means del P. Del P means change in momentum. Huh? By del T is directly proportional to force. But if you equate one constant is required actually, that constant is 1 only. So that is why you can directly write F equal to del P by del T. You can write this also like P final minus P initial by T. Okay. This is the actually second law. From this second law, we can do some numericals. Okay. Then the third law, you please try to understand. Third law is what? Try to understand. Huh? So there is a wall. Okay. I am pushing the wall. If I push the wall by 5 Newton, the wall will also push me back with 5 Newton only. Simple logic. Simple. Equal and opposite forces. But they don't cancel each other, huh? Because you see, my force will be applied on the object, wall, and wall's force will be applied on me. Okay. So that is why they don't cancel. But if they applied on the same object, now say this is the object, so from this side, say it is 5 Newton. Say from this side, another boy is pushing it by 5 Newton, then only net force will be 0. Okay. But in my case, you see, say this is the wall. Okay. So I am pushing the wall with 5 Newton, and the wall is pushing me back with 5 Newton. Okay. So they don't cancel each other. Okay. Because for me, only one force is there, 5 Newton. For the wall also, only one force is there, 5 Newton. So they don't cancel. But if same, if on a single object we get two equal and opposite forces, then they cancel. Okay. So what will be the third law? For every action, there is equal and opposite reaction. To every action, there is equal and opposite reaction. But with that, you have to write one more statement. The action and reaction takes place not on the same object, two different objects. Okay. Action and reaction takes place on two different objects. It is actually in universe, any two objects, if they are having mass, they attract each other. Remember, in space, yeah, everywhere. If you are having two objects having mass, say this is an object, okay, it has some mass. Say this is M2, and this is one another object, it is also having mass. Say it is M1. So definitely they will pull each other, okay, they will pull each other. So this is the force. This force is called force on 1 by 2. Force on 1 by 2 means 1 is experiencing, 2 is giving the force. So similarly, this force, what will be the name of this force? Can you say? What will be the name of this force? The first force is
Sir.
F. F21, it will be F21, means force on 2 by 1. Okay. If but
Yes, sir.
their value will be same. Value will be same. F12 equal to F21, but with a negative sign. Okay. Why negative? Because it is vector, na? They are opposite in direction. So this is called actually Newton's third law. Okay. This is called Newton's third law. And so Nitish, if the meeting gets over, na, so you click on the same link and join back, okay? Because I'll continue the class up to 9 o'clock, okay?
Okay, sir.
Derive F equal to ma from second law. This is also called Newton's law of motion, okay? So, see, you know that F equal to del P by del T, okay? Change in momentum by, okay? So it is nothing but P final minus P initial by M by T. But you know that momentum is nothing but mass into velocity, okay? Final velocity symbol is normally we take E, okay? And initial velocity we normally take U. So mv minus mu by T. So you can take M common, na? V minus U by T. So it is nothing but F equal to M into, you see, V minus U by T is nothing but A only, okay? V minus change in velocity by time is called A, acceleration, okay? If you want to write in vector form, all are vector, okay? You can keep the arrow. Mass is scalar. This is called F equal to ml. And again, I am saying, how can you get that A? You see, you know that V equal to U plus AT, na? So it means V minus U equal to AT. So it means V minus U by T equal to A, okay? The acceleration is change in velocity by time. The depth A is put here, okay? Instead of V minus U. I hope you understood. You understood what is F equal to ma? What is F?
Force.
You are saying force, and I am saying external force. Which one will be more correct?
External force.
So you please write net external force, okay? M is mass, A is acceleration. Definition of acceleration is change in velocity by time, huh? Definition of acceleration. Definition of acceleration is what? Change in velocity. Change हमेशा final minus initial. Change is always final minus initial. Difference is always bigger minus smaller. Change is always final minus initial. Let's say this is a vector equation, na? So if you write the vector equation along x-axis, so this Fx means net force along x-axis must be equal to mass into acceleration along x-axis, okay? Or if you write the force along y-axis, okay? Normally we take vertical line is y, normally, okay? It is not necessarily that always you take vertical is y, but normally we take horizontally rightward x-axis. So if you write along x-axis, so Fx equal to max and Fy equal to may, okay? That is the advantage of vector equation actually. So here actually Fx is what? Is the net force or net force along x-axis. This Fx, what you should read as Fx. Fx means net force along x-axis. Net force along x-axis. So what is Fy? Net force along y-axis, okay? Y-axis. That will, if that is there, then you can use that also, but not required actually, okay? We need up to class 12 only, only two-dimensional motion, not three. So that is why we take only two coordinate motion. Okay. a particle of mass 2 kg. As a particle and object, they what is the difference actually? Dimension of particle is almost zero. Okay, an object is a multi-dimensional thing. Okay, particle means a dot point, like nothing else. Okay, a particle of mass 2 kg changes its velocity from 2 meter per second to 10 meter per second in a time interval of 5 seconds. Find the value of net external force on it. Okay. So, according to the question, m equal to 2 kg. Okay. And the final velocity is v. V is what? 10 meter per second. Initial velocity is what? 2 meter per second. And time interval was 5 seconds. Now we need the force. So you have to remember the formula. We know F is equal m e minus u by t. So m is 2, v is 10 minus 2 divided by 5. So 10 minus 2 is, it is altogether it is 16 by 5. And the answer is Newton. M equal to 2 kg, V equal to 10, U equal to 2 meter per second, T equal to 5 seconds. So M V minus U by T, V is 10, 10 minus 2 is 8, 8 to the 16 by 5. Is there any doubt?
No, sir, no doubt.
No,
Understood
sir.
now? Okay. So let me try another question. Starts moving. Starts moving means initial velocity 0. Let us see. Given that m is equal 5, v is equal 20, u equal to 0 because start t equal to 2 seconds. We know f is equal m e minus u by e. F equal m is what? 5, 20 minus 0 by 2. So f equal to 50. SI unit of force is Newton. Yes. find the force on the object of mass 2 kg if its velocity changes as shown in the figure. In the graph. In the graph here. This is V, this is T for time, and velocity. This graph is this. This is the 2 second. This is in second. This is in meter per second. Okay. It will be given in the question. This point is 4. See, this is a straight line, huh? That is a straight line from 4 to. This is actually the graph, okay? See, here, actually, from the graph, we have some information, okay? Remember, time always keeps on increasing, okay? So, initially you see time, when the clock starts, so time is 0. So, when time 0, the velocity is 4, you see? When time 0, velocity is 4. It means initial velocity is 4. And when time 2 seconds, you see this is 2 seconds, final velocity is 0. Are you getting it is 0? Because the graph is falling down to 0 only. Now this point's coordinate is 2, 0 only. And the time taken is t final is 2, t initial is 0. So 2 minus 0 is 2 seconds only. Okay. So what is, and mass is already given. So what is the force on the object? The force on the object is m v minus u by t. M 0 is this time answer negative, huh? 0 minus force can be negative because it is a vector quantity. Final velocity is 0, initial velocity is 4 by 2. 2 into minus 2. Minus 4 Newton. And remember, minus 4 Newton has some sense. Say this is the object. It was going with velocity 4 meter per second. So someone has to apply a force in this direction. Then only its velocity will reduce to 0. Then only it can be stopped. This force may be a friction also, nothing else, okay? But whatever it may be, that final velocity, it has to make 0. So hence the force will be in reverse direction. Do you understand this? Can you
Yes, sir.
Yes, sir.
Okay. They are saying a simple question, okay? Simple question. So this is 2 kg and I have pulled it with 1 Newton and from this side F is 3 Newton, okay? 3 Newton. Okay, right direction I have applied a force 3 Newton. On the left direction I have applied a force 1 Newton. So find the acceleration. So in this section, what we do, you see, say this is I have taken as x-axis, okay? This is y-axis, okay? So I'll write the equation along x-axis. Okay, okay. So how can I write? I know that fx equal to m into ax. Okay. Force along x-axis equal to mass into acceleration along x-axis. I know it. But remember, it is total force, total force. Total force also given by this symbol, okay? That is called summation symbol. That is simply symbol, nothing else, okay? That is called summation. So now you see, it is 3 Newton, okay? Say I am taking the right direction as positive. But this is 1 Newton, no? I have to take -1, okay? Equal to mass into acceleration. Remember, right direction, if I take positive, left direction will be negative. Okay, that is very important because force is a vector pattern. So 3 minus 1 is 2. 2 equal to 2ax. So it means 2 by 2 equal to ax. So it means 1 equal to ax. So ax equal to 1 meter per second square. That is the answer. Remember, in my next class, I'll do lot of question of this type, okay? Because I have to, this is the very use of F equal to ma, okay? We are going to do lot of questions using F equal to ma formula, okay?
Sir, what is summation?
Summation means what? Actually, net. Summation means addition, add all the forces, okay? You
Okay,
add
sir.
all the summation means addition. But remember,
Okay, sir.
you have to add it vectorically, okay? Right direction, if the right direction is positive, then left direction will be negative, okay? That is very important.
Okay,
Because
sir.
force is vector quantum. Okay, on that note, I am going to wind up today's class, okay?